Hey guys, it's Jake and Mari, and this is the big picture with Lee Wheelbarger. Today is May 16th, 2017, and today we're going to talk about the current G1. We'll start off with talking about the current G1 storm that we're in right now. As you see, the solar winds are elevated to 625.4 kilometers per second. Today is the sixth straight day also without any sunspots. And right now we are sitting at 36 for the year. And last year we had a total of 32. So we've already surpassed, as we said in the previous show, that stretch has continued to grow. And it doesn't look like, we were just looking at a picture of the sun just now, checking out the corona holes, but I mean, normally you could probably see something popping up on the left-hand side in the back, but it's really hard to tell how much longer we're going to go without a spot.
Well, I think we'll get some more spots. The electromagnetic field of the sun gets so weak that we don't have any more spots at all. We still will have a few more coming out. I mean, the sunspot average of what we're getting. So, we're basically at zero. We're at day 8 and no spots, but the average is saying 36. It's like we had talked about on one of the other shows of, how the average is done as opposed to what the real sunspot count is. And that number will continue to fall as, we progress out of this solar cycle and into the next. It will be interesting to see if we will see sunspots at all for next solar cycle. And when we talk about the magnetic fields in the sun, we'll actually be asking Valentina Zarkova on that coming up here in the near future.
Yes, and before I mention that, you were talking about the next cycle, and I think I understand why you've been jumping up and down about what's going on with the sunspots. Am I correct in saying that we're not even at the peak yet of the solar minimum, and we're already en route to get the same kind of numbers that we would get in a solar minimum? What, we're 2 years out from the peak?
Yeah, from the valley, the lowest point. We're not even there yet.
We're on track right now. We're on track for probably about 120 to 150 spotless days. I can only imagine how much more we'll have next year or not have next year.
Well, it's like I was saying on one of the other shows. Right now, we count spotless days in 10s, 20s, 100s. Before all of this is over with, there will be a period of time of where we don't see sunspots for 1,000 days, over 1,000 days. Because once the magnetic fields of the sun become so weak, the magnetic field that is required to produce a sunspot strong enough to do that. And so because of that, it won't make a sunspot. It's just like your car battery being dead. There comes a point when the battery gets so dead that it won't crank the car anymore. It just sits there and sparks, and clicks at you. We're getting to that point. As we're going down in the cycle, it will get weaker and it will not be able to create those sunspots. The magnetic field is no longer present that is necessary to make that happen. And so the sunspots will go away and we will continue to cool. We will get 19% more galactic cosmic rays coming in throughout the remainder of this cycle. So we have that to look forward to. And it's just going to continue to progressively get more cloudy, more atmospheric compression, more of these storms, more of these rain, hail events, massive crop losses that we've already seen. You've already seen the prices going up. They said 30% loss of wheat crop in Kansas. I say in excess of 50 by the end of the season. So yeah, there's a lot going on around the world. There's unbelievable flooding taking place. I think it's in Peru. There's massive storms going through France, Italy, Russia, Serbia. I mean, there's 20 major storms that have taken place in the last 7 days that have been absolutely catastrophic. Each and every single one of them individually or catastrophic. We are now going to start coming to a point of where these disasters are no longer catastrophic. They will be referred to as biblical type events. And, you know, these things have happened in the past. They do happen. They happen regularly, you know, and we're talking on a cosmic time scale, not on a human lifetime scale. But, you know, so we have the 200-year flood. Everybody always talks about the 100-year flood. They always talk about the 200-year flood. Well, folks, all of those 100 and 200-year floods all take place in about a 30-year span, not over the 200 years. It's 206 years between them. We have 176 years of warming, of which we have just completed, and then we have 30 years of cooling, of which we are just starting into. So this is when this happens. Major volcanoes will go off, seismic activity, you know, all kinds of volcanic activity is already happening. It's up dramatically all over the planet. And then we have, of course, the giant coronal hole streams, which are putting more energy in, and it just goes on and on and on. And every little part of it is a small factor. But when you add them all up, you always come out with the same answer, and that is we're going to get colder.
And back to the coronal hole real quick. I was looking at this as you were talking down here at the 530 position. It appears to be some kind of a release at the same time that. Did you see that down there at the bottom where my cursor is?
Yeah, it's magnetic umbral letting go down there, and that's what you've got to worry about.
The whole thing.
Yeah, that's one magnetic umbral going across there. That's a magnetic field line, basically, is what it is. And it's not so much of an issue when they let go and they just like retreat back a little bit or something. That's not the real problem. It's when one end of that thing lets go and it whips out everything with it. It's just like a bullwhip, and it just whips out into space. And when it whips out, it grabs a hold of all kinds of particles and energy that's coming out of the sun, and it throws it at you. And it's, you know, it's like getting hit in the face with a snowball. But in this case, it's particles. And they come right at our planet, and they do all kinds of funky things when they get here. That gives us the aurora borealis. That gives us power outages. It can give us increased nucleation, cloud nucleation, because it's increased particles in our atmosphere. Causes, if it's an abrupt shock that hits the planet and we aren't already in some type of a coronal hole stream or something of that nature, can trigger large earthquakes in excess of 6.0s. So, you know, these are the things that we are just now learning and understanding about what our sun does and its interaction with our planet. We realize that, oh my God, this is doing this. And then we can look back in our history and see, now that we know that, okay, the galactic cosmic rays went up, this is what it does. Well, let's see when that happened before. Well, then you look back in history and go, wow, every 206 years or 400 years or, you know, whatever cycles, you can go back and see it. And it's just a recurring cycle, and we're going through it. The thing about it is that nobody on the planet has ever lived through it, because nobody on the planet's 206 years old. So people don't recognize it. It's only through technology that, you know, and the ability to look back in time 20 million years that we can actually see what's happening. So that's, you know, it's just a cycle that we go through and just deal with it, because there's nothing anybody can do about it except for deal with it.
Yeah, and a lot of people are still critics. I hear it a lot. You know, what makes you think this is going to be the one that puts us back into a cooler climate? I mean, we get minimums all the time. What is it?
That's a simple question to answer. The difference between this and other minimums is very, very simple. First, look at all the minimums prior and the levels that we were at as far as TSI and global temperature. We are already on our downward trend and have been for in excess of, I think, 3,000 years. So we already know that. Secondly, when you look at this epoch, this warm period that we have, these normally average about 10,000 years. Currently, we're about 11,500 years into this one. So we're already 1,500 years overdue for going.
Okay.
3.
No. Okay, go ahead. Finish. I'm sorry.
So 3, you have the when you look back at the previous little ice ages, the devastation that it caused, the fact that the New York harbor froze solid and George Washington was able to cross it on horseback pulling cannons to attack the British in New York City. We've never seen anything like that in any of our lifetimes, but New York harbor froze solid. The United States only has 2 icebreakers, and one of them is in long-term service. So in addition to that, you also have, when you look at Valentina Zarkova's work and how the electromagnetic fields are collapsing or fighting each other, going 180 degrees out of phase within the sun, and you look at the weakness that that will cause, the instability that that will cause, and the duration that that will take place over the number of solar cycles. One bad solar cycle, it's multiple solar cycles that we will go through. So we're talking 30, 40, 50 years of this. Then you take and you calculate the increased number of galactic cosmic rays that can come in, because got to remember, we're already up 14.5% cosmic rays, and we're going to go up yet another 19%. So when you add those two together, and then you calculate the 100-fold increase in cloud nucleation created by that, and then you do the math and you calculate the 35% reduction in TSI hitting the planet, and because of the fact that those cloud nuclei are smaller and contain less water droplets, they won't hold and store the thermal energy that we have, and they won't hold and store what they're getting from the sun either, because they're wider, so they're more highly refractive. So they will refract more energy out into space. Then you take and calculate how much snow will fall, because you have that much additional cloud cover, and how much snow cover that will create, and permanent snowpack that stays year-round, kind of like they're going to have in California for the first time this year, because you got to remember, they got 80 feet of snow. Skiing in July in California, totally unheard of until you get 80 feet of snow in 1 year. How do you get 80 feet of snow in 1 year in California when just a few years ago you didn't get any snow at all? It's called global cooling. So when you add all of this up, and the refraction that there is, the drop that that will create on the face of the planet, the amount of cloud cover over the planet, it's gonna be 50, 60, 70 years before we even think about coming out of it. And will we then? I don't think so, because we are already on that downward track. So however long it takes to go to full glaciation is however long it takes. But what some people don't realize is when you look back 20 million years, you will find that we go from temperatures than they are today to temperatures that are much, much colder than a minimum. We're talking full-blown glaciation, and that can happen in as short as 3 years. So when you look at all of the factors, you actually do the math and add it all up, it all adds up. So, anybody can say, well, why do you think this? It's real simple. Go look at the facts and do the math for yourself, and you will see, because all the numbers that I'm spitting out, anybody can find. They're all over the internet. All you got to do is just go look for them, just like we did.
Well,
okay?
and I wanted to ask you real quick. I wanted to ask you real quick too about that. When we talk about TSI and you go to the internet and you try to get a TSI reading, you go to NASA and you get a 1365, 1364 reading. But then you go to the website that I prefer to go to actually, the Colorado, the University of Colorado, and they've been reporting TSI about four notches lower than what NASA will report it. Is there a reason why we're getting such a difference in between the two?
Well, It used to be, they used to say that there was a calibration difference between the instruments, and then they actually did calibrations and found out that there wasn't a calibration difference really. They were all actually seeing about the exact same thing. And then people started injecting things called averages. And when they started putting these averages in, then you don't get the real number, you get the average number. So we just mentioned a prime example of that. If you go to NASA's website today, it says that we have 36 sunspots on the sun. Do we? No. There are no sunspots on the sun. Okay, we're in day 8 of that, or whatever you were saying.
Day 6.
Okay, day 6, excuse me. So we're in day 6 of that. So the difference is, if you go to NASA's website, they'll tell you that there's 36 sunspots. Are there? No. There haven't been any for 6 days. That's the real data. There haven't been any. It's just like the TSI, University of Colorado, is real data. That is what is there today. You go to NASA, look at what they're showing you. Guess what? You're back to your averages again. So their numbers are always higher. And on how they do their TSI, I've researched that and researched that and researched that, and I still can't find a real answer as to how they come up with that higher number. And I've been wanting to know that for about 3 years myself, because they won't tell you that. They'll just tell you, oh, this is what the TSI is. But when you go to the University of Colorado, who are, as far as I'm concerned, the official folks, that it's much lower than what NASA says. And if you look at the projection of the drop-off into a solar minimum, and you look at things like the Dalton minimum and the Maunder minimum, and you look at the TSI during that particular period of time in history, you will find that we are already below those TSI levels. Well, the Earth is cooling.
And that brings me to my next question too. You know, the last show we did, we put a line basically in between the Carolinas and went straight across the country. If somebody wants to try to rough it and go through it and try to get through this, I know I was discussing with Mario earlier today, we were talking about solar energy. If the TSI is low now, are we going to be able to rely on solar energy in the next 2 to 3 years when there's more cloud coverage than what there is and the TSI is even lower?
Yes, you can, but not at the current levels. Expect only about a 50% output from that panel once you start getting cloud cover. So if you've got a 400 watt panel, congratulations, it's now only a 200 watt panel or 150 watt panel, depending upon where you're at. In that condition, you know, of total cloud cover, you want the best panel that you can get, a 21%, you know, effective panel, and in total cloud cover. And when you know it's going to be total cloud cover, you want it on a high point so you can see as much of the horizon as you can, and you want to mount it flat. You'll actually get a little bit more energy by mounting it flat under total cloud cover than you will by aiming it towards the sun. I know people who put in solar go, well, that's crazy, Lee. But, well, go do the research and you'll find out that I'm right. You know, that's documented. I don't have to, you know, laboratories and manufacturers have already done that and proven that. Sun Power is a prime example of one of the manufacturers who has already done that testing. In fact, I consulted with them when we were designing my yacht. So, you know, they will give you the documentation, and other people will as well. So, you know, that's one thing that you should do, is get more solar panels, because you won't have the output, just like you were saying.
Yeah, we were also talking too. We had a pretty abundance of sun today. For once, last couple of days have actually been fairly pleasant, and the current temperature here in my part of the woods, we are in the middle to low 60s right now, middle 50s to low 60s. And with all the sunshine that we had today, the fact that we barely broke 60, it's amazing to me to be kind of like we were talking, Amari and I were talking, it was like a fall day. It felt like a cool, crisp fall day. Not like you would normally feel it, even for New York standards. Still a little chillier. So it just makes me wonder, you know, that cold air that's spilling in from Canada still, it's affecting the upper Northeast for sure. And with that kind of sunshine in May, and as long as the light we are having, it should be a lot warmer, at least about 10 to 12 degrees warmer than what we're dealing with right now.
Oh, farmers in Georgia can't get their crops to grow because it hasn't warmed up enough. Just a few days ago, I'm in Central Florida. It was 53 degrees down here. You're in upstate New York.
Yeah.
I'm in Central Florida. It's 53.
Yeah.
You know, hard freezes here this year.
What's your temperature right now?
It's warmer than that right now. We're probably in the 70s. Just about what it feels like.
Well, I know we got a warm front coming in. We're at that part of the jet stream where we're going to see some warmer air come back into the picture, but also just as fast as it came into the picture, it's going to be gone. So, and just showing that the jet stream hasn't really changed much. We're still seeing that. We're still seeing the. Yeah,
you're still seeing the blockings of the wavy up and down, which is what it's going to continue to do. That it's only going to continue to become more elongated. And see, now that right there, that's beautiful. Do you see right in the middle of that, right above the equatorial region, where you've got that deep V right there with the dark blue spot in the middle of that?
That right there is.
Yeah, right there. Okay, now that right there is a prime example of where you can have some of the nastiest weather you ever did see.
Well,
because what you can have is you can have hot air, cold air, and wet air converging there all at the same time. You get unbelievable lightning, unbelievable rains. There you go. Yeah,
that's what
right there.
That's what we're getting ready.
That's what it does.
Yep, that's what we're getting ready to see. Right there. Before we even look at the radar, Lee picked it up just through looking at the jet stream. But yes, we're gonna be seeing snow and cold temperatures. Mara and I were looking at the map together the other night, and we were seeing 30, 40 degree temperatures in New Mexico, Nevada. You know, it's going to be towards the end of July. Like I was telling you, we're getting ready to get a warm up here in Western New York. I do believe we'll peak out at 80 degrees on Thursday, but by the weekend, we're back down in the mid 60s, and the future outlook doesn't even have us past 64 degrees by the end of May. So again, I know I live in a country where it doesn't get super hot, but it still gets summertime temperatures. And right now it feels like mid-fall.
Yeah, and it's like I said, it's only going to get worse. This is just the beginning of it. And it's even down here in Florida, when the cold air moves in, feel a burst of cold air coming down, and it just puts a chill across you, and then it warms right back up. It's like it's a little pocket of cold air that has wisped it down to the surface, and you just feel it in a breeze. It's here, because you know what's happening, and you're walking along, it's 80 degrees outside, and all of a sudden it just feels like somebody opened the door on a walk-in and cold air enveloped over your body, and then a second later it's gone.
It's looking at this map is just amazing to me to see this kind of pattern in this time of the year, and watching the cold front dip all the way. It's like the cold front line just snaps and goes all the way down to New Mexico.
Right. And that's what's going to continue to happen, but it'll even go even further down. We're going to be going all the way down past the southern end of Florida, down towards Cuba, and down towards the equator, probably all the way down as 15 degrees latitude, both north and south of the equator. Continue to get bigger, and the violent storms between each one of those fronts will continue to get worse. And this is where we will see these biblical storms of hail and ice, and atmospheric compression events, atmospheric rivers.
Boy, it really seems to try to get its act together when it gets into the Northwest. Anyway, moving right along, back over to one of my new favorite pages here, spaceweathernews.com. Lee, you're the one that got me into this web page here. I've looked at a lot of pages that have a lot of information. I don't see anything in here not to believe. The food watch video I didn't get to watch today. We were talking the last time we had a show about the drum beats starting to get a little bit louder with the possibility of a food shortage. And I know some folks, the first thing they want to do is laugh at you and, oh, you're just being a doomsday sayer. But I don't think there's nothing wrong with being aware of a possibility. If it's not getting cold, just with the extreme weather alone, with all the floods and the storms that we've got, the hail damage will destroy crops. The flooding will destroy crops. And of course, what our natural weather we're having right now with the total cloud coverage, that alone, it won't give enough light to certain crops to grow properly. So I don't think it's too far-fetched to go out there and say, he might be pushing the fear button a little bit. I think it's appropriate to kind of think about these things, because we're seeing a lot of crop loss already, and we're not even getting started yet. So that's concerning.
Well, you were saying possibility. Well, we're beyond possibility. A possibility is there is a chance of something happening. Okay? Yeah, you're driving down the road. There's a possibility your tire could blow out. That's a possibility. You carry a spare for that. Okay? But if I say you're driving down the road and your tire is making rotations as you're driving down the road, and I say, you know what? It's going to rotate again before you move from here to there. That's not a possibility. That's a probability, because that's something that is continually happening, and we have recorded it back through history, and we see it happening.
Well, we see it right now.
We can measure it.
We see it happening, Lee, but you also have to understand too, the mainstream, unless they don't feel it in their pocket, they're going to be the naysayers. But I think,
well, I understand that.
I think you're on.
All I'm defining.
I think you're on.
All I'm defining is the difference between a possibility and a probability. It's no longer a possibility. This is now a probability. We've moved well beyond possibility. Okay, when it's already happening and it's measurable, and you can go back through history and see it over 20 million years, and this is doing the exact same things that it did before. The only difference between this time and the other times is it's faster and it's worse, and it's going to be worse, and we can see that. Okay, so you can guarantee that we will do what we did before, because we're already going past that. It's kind of hard to say that, yeah, we're not going to go off the edge of the cliff when we just passed the cliff 5 feet ago.
What's the chances of cycle 25 or 26 throwing us a curveball?
None. There's no chance of that. We are on the downward trend. You can go back through all of the last 5 solar cycles and see that downward trend and how much we are losing. And that downward trend is cutting the number of sunspots in half, basically, as we continue down that. So we went from 170 or 150 to 75, 35, 36. Ta-da! That's where we're at. The next one, it'll be 18. But guess what? I don't think you're going to see it, because that's where Valentina Zarkova's work comes in. So if we do see it, we'll only see it for the first part of it. I don't think it'll be all the way through that cycle until the magnetic field becomes so weak that we don't see sunspots at all. And so again, it's all math. Anybody can go do it. Research I did. They can contact the people at CERN. They can look at the documentation that's all peer reviewed from predominant people at CERN who have been there for 20 years, 30 years. So I think if you've been there that long, you kind of know what you're talking about. That's why they put you in charge of these massive projects like the Cloud Project and confirming the work of Heinrich Svensmark. And other people have now confirmed the work of Valentina Zarkova. So she's not the only one, along with her team, that is saying that. Other people around the world have went back and pulled the exact same data from the Galileo spacecraft and from the Wilcox Observatory in California, math, and came up with the same conclusions, because that's what's happening. I mean, look, it's not difficult math. You to lose power out of something, then that is a trend. Okay, so if you can measure the power coming out and say, okay, yesterday we were at 1,000 watts. Okay, today we're only at 900 watts, and the day before yesterday we were at 1,100 watts. We have a downward trend of losing 100 watts a day. Our sun's doing that, but it's a lot more than 100 watts. In fact, we've already lost close to 50% of the solar wind stream over the last, 6-7 years. So it's already happening. It's measurable. People around the world see it. People around the world are talking about it. People around the world are concerned with it. And people around the world are trying to prepare for it here in this country as well. The difference between this country and other countries is our media won't talk about it. In other countries, they do. So, there are people who still are on the CO2 bandwagon and have paid to be, or get perks for that, or get their research grants for that, or whatever, and they're going to ride that gravy train as long as they can. And there are still people who are dumb enough to believe that. But anybody with a brain in their head who wants to do the research can go and do it and see that all of that was a load of malarkey. And we know that because when you look at what they have in their models and you look at the actual data of what the Earth can and does do, you will find that the parameters of what the Earth can and does do, along with the sun, are way beyond the parameters that are inside their model. Additionally, you will find that their model is one of the most inaccurate models that's ever been produced. They have yet to produce a model that actually shows what the climate has done or will do. The majority of the other models out there are using actual facts, not made up things. And they are accurate to within 97% of every part of that model as a complete solution or calculation to go by to compare to actually what transpired. So what they did was they went back in time, they put in the figures back then and said, okay, let's go forward 400 years and see what it is now. What would it be? And ta-da, they're within 97% of what it would have been. That's Valentina's work, and we can talk to her more about that.
Yeah, quickly, we have some exciting news coming up. We've been in contact with Valentina Zarkova. Lee has pretty much introduced me to her work over the last several months. I decided, and Mari and I both decided, to reach out to her and possibly try to get her on for an interview, and she has agreed. We're just waiting to hear back from her on what time and day works best for her. But so stay tuned for that. Here in the next week or so, we will have Valentina Zarkova as our guest. Lee and I will be asking some questions about her work. And Lee, you've followed her for a while. You can probably give everybody a little breakdown of a little background about her, if you don't mind.
Yeah, she has. She's originally from Russia, is my understanding. She, I think, works in England now, and she works at, and I can't remember the name of the university that she's at. Her team, with a bunch of other physicists, and her study is magnetic fields. That's what her doctorate or whatever have you is. PhD is in magnetic fields and their interactions, and she actually has patents and has written numerous papers on that, and is a highly respected scientist within the world arena. So we're not talking about Joe Blow from out in the middle of nowhere saying this. So that when she came out with it, people didn't want to publish it. People wanted to squash it. People, because it went against everything else, that everybody else was saying, to hide it. And finally, They brought it out, and of course she was chastised for it, and so on and so forth, but went back and done the same research. And the thing about research is, if you can duplicate it and all the math lines up, well then, hey, other people have done it, and yeah, this is how it works. Okay, or at least how we think it works. So has all of that. And so the Russian government and other governments have taken her work and other people's work, seen what they have done, and taken a look at the picture of what it's going to draw for our future, and are now acting accordingly and preparing their countries, preparing their militaries, preparing their nation for the change in the coming cold climate. And you can see that with China putting railways in out in Africa. You can see that in Saudi Arabia purchasing land in Arizona. There's a lot of this intergovernment mingling thing going on with large governments putting hundreds of millions, if not billions and billions of dollars into projects in other countries because they see what's on the horizon. The Chinese know it, the Russians know it, people all over the world are becoming more aware of it. And you know, Valentina is just one small part of all of these people. And you know, her research, which we'll talk more about, has pretty much shown that these two magnetic fields are going to be fighting and create instability and a decreased magnetic field so that the sun won't be able to produce the sunspots.
And
Okay.
folks, here's a new part of a new segment that we're going to start doing here every show. Is Lee and I have talked, and we want to be able to provide not just information on what's going on with our weather, but as well as some survival tips. Lee and I were talking about alternative heat sources last night because, again, some folks may not have the desire or the means to move south, and there is ways to thrive in the grand solar minimum. Lee, if you could tell us about what we were talking about last night. We were talking about alternative heating sources.
Yeah, so years ago, we put together, it's a 55-gallon drum, and you can look it up. In fact, I think I have to send you a link on YouTube to it. They call them a double barrel wood stove. Now, my design for a double barrel wood stove is a little different than other people's, and I'll tell you that in the description. But basically what you do is 5-gallon drum, you lay it on its side, and you have the end that has the caps in it. And so you want to take the larger cap down at the bottom. So what you want to do is have a pipe that goes on there and pulls fresh air from outside in, rather than taking the warm air from inside your house and sucking it out of the house and running it up the chimney. So you turn the bottom barrel that way, you weld another barrel on top of it, you have a pipe that goes between those two barrels. So you've got two barrels on their sides, one on top of the other. And then in the top barrel, you weld a plate that goes inside of it from the bottom all the way across on the sides to almost to the top. So is that when you put your wood in the front of the bottom barrel, you're going to put a little door down there, and you can buy a kit to do this, by the way. You know, very easy to do. So you put some legs on the bottom of the barrel. You can either put sand in the bottom, or you can put bricks in the bottom as a liner in the bottom of it. You have the pipe bringing fresh air from outside into the bottom of the front of it, so you're not taking your hot air. When you have your little fire in it with the door open, you close the door, the heat builds up inside, goes up the pipe from the bottom one in the back of it, away from you, the far end, away from the door, comes up into the bottom of the top barrel where the hot air hits the metal divider that I was talking about. The air has to then come to the front of the barrel, go around the divider, and then go back to the back of the barrel before it goes out. That's the way that you can steal the most heat out of your smoke before it goes out of the top of your house. So that's a quick and easy thing to build if you have a little bit of experience in welding or have a friend who is a welder. It's cheap, they work very, very well, and you can use them for years. You know, you're talking a regular wood stove is going to cost you anywhere from $500 to $1,500, and you can probably put one of these things together for $100, $150 at most.
I was showing pictures of some of the different types of homemade ones. Some of them are really nice. Some of them are pretty rustic and to the point. But as I'm looking at them, and just from talking to you about it last night, seeing the image now helps versus just hearing about it. And I see what you mean here. We've got the bottom one where you put your wood in. There's your pipe that connects to the top one. And also, like Lee had said, the first time you light one of these up, you want to do it outside first. You'll smoke out your house. We're not trying to get anybody killed of carbon monoxide poisoning here. But this is
and you can see right on the one you've got there on the screen. You can actually see the hole in the bottom of the barrel of the face of it, right there. Yeah, that's where you put your pipe to pull fresh air into the stove from outside, and then you just put a little quarter turn valve on that, and you use that as your damper, and it'll keep your house a whole lot warmer, because normally a wood stove or a fireplace, the air that's going up the chimney, it has to suck in through the walls of your house. So it comes under the doors, it comes in around the windows, any cracks anywhere, it pulls that cold air into the house, and then the wood stove has to try to heat that. Whereas that if you have a tube running from the wood stove to the outside, it's pulling all of its air from the outside, and the warm air stays inside the house, and it keeps the house much warmer with less wood.
Let me ask you, and this might be pretty funny to you maybe, but I'm not too handy when it comes to inventing or putting something together. Let's say, for instance, you live somewhere where you don't have a chimney. Can you run the exhaust out through a window and just, maybe put some plywood to fit the tube that's going to carry the smoke out of the wood stove into the outside?
You can, but around that plywood, where the wood stove is going through that plywood, you need to have a metal flange around that, so as that the wood stove pipe is not directly against the plywood, so it doesn't catch it on fire.
There you go.
And always make sure that the coming up goes into the bottom of the pipe that's above it. Okay. That'll always make sure that the smoke doesn't come out in your house and it goes out the chimney like you want it to.
Well, Lee, I want to thank you for this little segment here, because that's probably one of the number one thing that I worry about if I stay where I'm at. Mari and I, we have kids, we have family, and what are we going to do about heat? What are we going to do about electricity? We've talked about solar, which we'll mention in the next show. Now we're talking about heat, and slowly but surely the plan is starting to come together. At least we have an idea of what we're going to do. So again, I really appreciate you bringing these ideas, and hopefully every week we can bring a new idea about how to thrive in the Grand Solar Minimum, because I think that's the most important thing right now. Is not just, we're not trying to scare anybody into, the worst is yet to come, but we also want to get people ready for the worst. And I do believe with what we've looked at and everything that we've monitored, Lee, I'm getting more and more sold into what you've predicted and what you're forecasting. You haven't been wrong too much. And like I said, like you said, look it up for yourself. And as long as you understand some of the data, what it means and what it does, the information is pointing to where you're saying is going to happen. And that is, we're not even there yet, and it's going to get worse. We're going to get colder, and it's going to be impossible to grow anything. I think you said above the 35-degree mark or below.
Above 45 is where it's going to be really difficult. That's a little farther north. It around the 30-degree to the 45-degree mark, you will have times where it is very difficult to grow. Where they will have the most difficulty is above 45. They won't hardly be able to do anything up there. They're saying that basically it's from the equator up to 15 degrees, no big deal. 15 to 30 degrees is questionable. 30 to 45 degrees, you're going to have some problems, and 45 and above, it's going to be extremely difficult.
I'm trying to mark real quick on my map here where we're talking about 45 degrees north, or are we talking west?
So it's up above. It's about Seattle, Washington State, Oregon on the East Coast. It's
Gotcha.
up around Connecticut, somewhere along in there, New York.
So up here, and you know, and not too generally do we have a lot of. I don't think we rely on a lot of co-ops up this way, but here in Western New York, we fall in that category. So that, you know, if you are going to try to be self-sufficient, you might have to move it indoors for a little while.
Yeah, and that's one of the things that we're testing right now with our test plot that we have here. We're getting ready to test a new, which is basically a organic soil that's a sandy loam type soil, and we're mixing that 3 to 1, so it's turtle dust, 1 part very good topsoil, and we're mixing that together to use that as a planting soil for root crops. And it allows them to grow easier because it is a softer material for them to penetrate, as well as it will hold the moisture because 3/4 of it is sawdust, so you have less of a chance of evaporation. But in the soil much better. So you don't have to put as much water on the plant. It will continue to hold it in the pot as opposed to running out on the ground if you overwater. So yeah, there's lots of things that we'll be able to bring to the public that we're doing. In fact, I was just on the phone with the University of Florida today about LED grow lights for crops in the field, and I'm starting a project down here. We were working on it today to illuminate almost an acre LED lighting to increase the daylight hours to see how much we can increase our yield, because we're going from 13 hours of daylight to 15 to 18 hours of daylight, depending upon where we are in relation to the summer solstice.
Interesting. Well, Lee, I think this would be a good point to leave off for this episode. I want to thank you again for coming out and giving us your input. It's always appreciated, and looking forward to our next one. Do you have anything you'd like to say before we head off?
No, I just appreciate everybody listening, and I hope everybody will actually go and take a look at the facts for themselves, and and be able to draw the correct conclusions, do whatever in their family to prepare for the changing climate.
Yeah, and what Lee's basically reiterating there at the end, we lost his audio for a second, but basically, folks, just you can do your own research. We'll try to start leaving more links in the description box. That way you can go check out some of the channels that we check out, as far as websites we go for our information. And hopefully we can get some links into some of the YouTube channels that are on the same page as we are. I know Adapt 2030 is the big one right now. So with that being said, we want to wish everyone a good night, and we'll see you again soon.